Hey Ellie,
But,
Eliana,
but,
do you want to learn about writing equations of exponentials from a graph?
yeah, you too. Enjoy.
Yes, that's right. We are going to be writing equations from graphs. So in this example, we have f of x equals a times e to the kx plus 2. Part of this graph f is shown below. So this graph right here is f. And it's given the y-intercept of 0, -1, and f of -3 is approximately equal to 1.41. So that's right there. We want to find the value of k to 3 significant figures. So there are two unknowns here. We have a and k, and as a matter of fact, we're actually going to want to find the a first. So let's do that. We're going to find a, and in order to do that, we're going to actually use the y-intercept. And I think you'll see why in just a second. So let's actually plug this coordinate in, this xy value, into what I have for the equation so far. So 1, or actually -1, is going to equal a times e to the k times 0 power plus 2. And that's getting a little bit crowded. So I'm going to actually, can I move this down? Yeah, there we go. That's what I'm talking about. Okay, so this is e to the k0 power. Well, 0 times k is 0, so I've kind of like removed the k unknown k problem altogether. And actually this e to the 0 power is just 1. So this is going to all come out to equal -1 will equal a times 1, or just a, plus 2. So now we've got a real simple algebra problem. Looking for a, I subtract 2 from both sides. A will equal -3. And that's great. One unknown taken care of. And now that I have the a value, I can use this other coordinate to find k. So now let's find the k value. In order to do that, we're going to plug in what we know and solve for what we don't know. So we're going to plug in for the y value. 1.41 is going to equal, using this a value, -3, e raised to the k times -3 power plus 2. And then this -3 is this -3 right here. So hopefully that makes some sense. All right, so I'll subtract 2 from both sides, and let me just punch that into my calculator. I think that comes out to be -0.59. It's going to equal -3 e to the -3k. Next, we'll divide both sides by -3. Divide by -3. And let's just kind of leave this as it is right now. So that's we can make them both positive, since that's negative divided by negative. So this is going to now be 0.59 over 3 is going to equal e to the -3k power. So at this point, I've gotten my exponent, or my exponential, isolated, and so I'm ready to solve for the variable. The variable's in the exponent, and the thing we use to get the variable out of the exponent is logs. So that's where the use of logs comes into this problem. So I'm going to take the natural log, since the base is e. So I'll take the natural log of this whole piece over here, 0.59 over 3, and that will equal the exponent, -3k. Divide both sides by -3, divide by -3, divide by -3, and maybe up here I'll squeeze in, I'm going to go here, different color, just so it doesn't look too busy. So k is going to equal the natural log of 0.59 over 3, all that divided by -3. And that's some number that is I can't calculate in my head, so we're going to go back to the calculator and get an approximation for this, up to 3 significant figures. So back to the calculator, I'm going to type in the natural log, so where are we? Natural log of, and I'm going to use this handy alpha y equals to do my numerator over denominator, and I want 0.59 over 3 in there. I'm going to hit enter. That's this number. I'll divide that by -3. Hit enter, and I've got 0.542. So k is approximately equal to 0.542. So So notice my solution is is for what k value is. And my solution isn't, I'm not giving as an answer the whole equation. Since this example asks for just k, I need to give just k as my answer. And it is a decimal approximation, so I will use those approximately equal to symbols. So hopefully that made some sense. I'm going to give you a shot to try the same problem in the next example. So this is a you try, pause the video, give this one a shot, and see if you can't find the k value for this function. And here is my final solution. You'll see my work out for the a value, and then also for the k value.